costs come down. Raw materials from mine or from here. Inside this enclosure, we have the anode and the cathode electrodes, which are very thin foils coated in an active material. Those are rolled up in a jelly roll and packed inside this very densely. The annulus, the extra volume outside this is filled with an organic electrolyte, and that electrolyte facilitates the transfer of the Li plus ions, and that's your current. So this battery we take and we arrange it in series and parallel. The same way you have a AA battery, you have a positive and a negative side, and then we connect the load to it, and that's what we do. So is making the slurry. So the slurry comes from we start with some raw powders and a solvent, NMP. Those are all mixed together in these mixing tanks, which are kind of like blenders. And we mix up that together and try to get a really homogeneous mixture. And then when we have that, we move up into the next booth, which is coating and drying. And we'll have a couple other people who can tell us a little bit more about that.
The mixing machine actually starts on the
solvent to make a slurry. We do that and pump it all the way down to the other end of this room, where it enters this massive oven. So we bring in rolls of aluminum foil, unroll them at the far end, and then also at the far end is a coating booth. And in a process kind of similar to like a printing press, we lay a very thin layer of that wet slurry on top of the metal. That metal then travels along the length of the oven towards us, and each chamber having a specific airflow rate in and out and controlled to a specific temperature to evaporate that solvent. So that by the time we're down on this end of the oven, that solvent's all gone, and we're left with a thin metal foil with a solid active battery material attached to it. We then turn up and go across. Essentially the bottom of the foil becomes the top, and we coat the other side. Send it all the way back down the other side, where we have a fully coated foil with two active batteries layers on either side of it. This oven used to be the single largest electrical load in the factory, but with over the last year or so, Panasonic and Tesla working together, we've actually redesigned this oven and the solvent system that goes with it to cut the electrical load by about 80%. So this is the first of many ovens. There's going to be one here in a few more months, going in parallel. And where you entered the building, that area is going to get built out with even more. So in our kind of our quest to getting to net energy neutral at this factory, cutting the load and all these big tools is kind of a very big deal for us. So yeah, okay. Yeah.
fit in the Dallas Cowboy football stadium. So that's a lot of dirt.
So in this next step, they're going to tell us a little bit about why those voids are really important and what we're going to do to try to eliminate them.
Factory design team. I'm based here out of the Gigafactory in Reno.
My name is Brian. I'm one of the engineers responsible for installing most of this equipment.
And we're going to tell you a little more about cathode press here, which is where we are. You just walked by 3 big hydraulic presses that are under these tarps. You guys just came from Coat and Dry. Saw the ovens there. That's where we evaporate all of the solvent that's used in the mixing process. Perfect. At this point, we're controlling the thickness of the electrode to its final thickness. So instead of the solvent, there's a lot of, there's basically porosities left over. We're trying to compress that to our target thickness. And we're looking for roughly the diameter of a human hair as our final thickness. So what we do is try to control that porosity to be able to control the flow of lithium ion into and out of that material. We're trying to compress as much as we can to pack as much active material as we can without disrupting the molecular integrity of the material itself to the point where the lithium ions couldn't really flow into and out of the electrode. So Brian will tell you a little more about how that actually happens over here.
Yeah. Walk you guys through the material flow for this space. So from Coat and Dry, the room you were just in, the coils now have that active material, and those will actually get loaded into this room behind us, so feel free to come in and take a look. This is essentially the material warehouse. So this is where we kind of store, well, yeah, they're still stored as rolls. There's a crane system that runs down the center aisle, and that'll actually go and retrieve a coil, bring essentially a magnetic strip roll it, and it's going to feed it into the press. So under these tarps, basically we have our hydraulic presses in here, one on top, one on bottom to compress the film from both sides to get that target thickness that Matt mentioned. The foil will flow through the equipment to the other side. It gets wound back up in a rewinder to get that coil shape again. It's loaded onto an AGV, transported back to the buffer rack, and it goes on to the next step in the process. Foil leaving the system is about half the thickness that it was coming in. And yeah, that's about it. Fairly automated process. The AGVs kind of load and unload the material. There are operators in the space that are monitoring the equipment, but for the most part, it's an automated process. They're just kind of fine-tuning and monitoring.
How much pressure you have to capture?
But to get down to the micron level, it's quite a bit. As you guys are making your way outside of the room, there's actually an AGV along the wall, that vehicle that transports the material, and it's sitting there charging right now, so take a look at that on your way out.
A nice old-fashioned automatic vehicle. Not as good as autopilot, very slow.
Next step after that is we take the anode together with the cathode, we put a dielectric in between so they don't short, and we wind them together. That's called winding, and then we slit them to get it to the right height to fit into the cell. We call that combined anode, cathode, and separator, we call that the jelly roll. That gets pushed into the can, filled with electrolyte. We pull out any gas to make sure there's no gas bubbles. And then we crimp the cap on it. And then that's really the end of the cell manufacturing process. The last step after that is called formation. Formation is where we do the first charge and discharge of the cell. And that process is really critical to some of the internal structure, and there's actually some chemical reactions that occur during that first charge and discharge. It's a very controlled, it's a pretty expensive process as well. We're gonna see the last part of that called cell aging, which is pretty cool. Tesla has been really fortunate to find a partner like Panasonic. 10 years ago, when we were just setting out on this journey, no one would give us the volume that we needed in cells, and Panasonic was the one that was willing to work with us. And building the Gigafactory together, it's a co-investment. It's really enabled Tesla to achieve what we need to. So I think overall the company has been extremely happy with how that partnership is going, and we really work together on innovating the cell and making this the best lowest cost battery in the world.
So, this is to store, to do the aging process. Days.
Welcome to Tesla.
Minutes.
Hello.
So you guys have kind of been seeing some of the start. This is the finish. So cells basically finished on the third floor. There's basically a big assembly process that gets made in order to kind of integrate both anode and cathode. Then once the finished cells are done, they come down here. Basically come in one of these trays, and then these racks are basically filled with a bunch of these trays with a bunch of these cells. Ultimately, these cells are basically a finished product. Once they're ready to go for Tesla, it's really easy. They just go 10 feet down that way. And that's a really one of the ways that we're really kind of vertically integrating the factory. Otherwise, generally the cells are made in one factory, modules are made in another one, and basically there's a big shipping process in between two. That's a lot of costs, that's a lot of emissions, that's a lot of other pieces as well. Yeah, so you guys are basically walking through B and robots and all sorts of different pieces, and to discuss more on that is my colleague Meredith here.
I'd like to know, how do you make this?
Who I am, yeah? So that's an AGV, it's an automated guided robot. You're probably familiar with us using robots in our manufacturing processes, which you're about to go see on the other side of the wall. It's super cool. Using robots to move materials around in a factory this big starts to make a huge amount of sense. Right, we're moving a lot of stuff, really long distances, over and over and over and over and over, and that gets really, really expensive. So we can leverage stuff like this, which we call our robot colleagues, right, to help us move material throughout the facility in a really efficient, really effective way. You heard Elon talk about the machine that builds the machine. that's the machine that builds the machine. That's one of the machines that builds the machine, right? It's really, really important to the overall flow of the factory. What you'll see on that AGV right now is these formation trays. Cells go into the formation trays at the end of the cell assembly process, and they'll live in this formation tray until we pick them back out in the Tesla process. What's really different about that is right now we get our cells from overseas. They come in cardboard boxes. 2 cardboard boxes would fit 1 tray's worth of cells. If you look at this cell warehouse, yeah, this fits tens of millions of cells in this warehouse. Think about all of those cells being in boxes, right? That's what we do today, because that's how we have to ship material. This really completely changes the game, right? Because we're under the same roof, we can have this total focus on sustainability and effectiveness, right? This tray can be reused for years versus having...
Right now, they say go back.
Come on down, guys. Come on down.
25 megawatt hours of energy storage boxes.
25 megawatt hours have been made in this factory, which is used for energy stationary products like the Powerwall.
Kilowatt hours, and the whole pack that gives 100 kilowatt hours. We sell that typically to businesses or utilities that are looking to defer and store their sealant around the outside rim. The top cover meets up with the bottom cover and we screw it together. It's pretty cool to see when the robots are moving. Modules inside the pod. Inside the module, some of these cells are arranged in parallel and others in series to get the right voltage we need for the drivetrain. The PCB that you're seeing here is part of the BMS. I know that's a lot of acronym soup right there. The BMS is the battery management system. That's what makes sure all the cells are operating properly and it controls the current and the voltage to each cell. The overall pod is the coolant channels coming in, and they run along the length of the cells.
How many kilowatt hours is this one?
This, what you're looking at, is 6.5 kilowatt hours, I believe, is the rated.
So, creation of the Powerwall. And people have to eat. And floor space, office space.
This is our Powerwall, which you see to your right. Powerwall has about 6.6 kilowatt hours of energy storage and is used for home use. We also take those pods and put them in a power pack. A power pack has 16 pods in it. It has 100 kilowatt hours of energy storage and is used by our industrial customers. For the home use, you take this, you plug it into your solar panel array, you charge it during the day while the sun's shining and you're at work, come home from work, discharge the Powerwall rather than going back onto the grid. Our industrial customers will take a power pack, they will charge it at night, for example, when the rates are very low and no one's using electricity. And then during the day, when they're consuming a lot of electricity, running the AC, they use it to offset the high cost of high utility rates during the day. To put in perspective some of the capacity of these units, if you took a 40-inch flat screen TV, plugged it into a Powerwall, and ran that on the Powerwall all day, all night, you could run that television for about 23 days, non-stop. Take that same television, plug it into a power pack, and you could run that television for 347 days, to give you a sense of how much capacity these units have. In front of me, we have a Model S chassis. here at the Gigafactory, we're happy to announce or to be making the batteries for the Model 3, as Elon mentioned earlier. Those batteries are going to have a similar design to our Model S, where they go underneath the chassis of the car. This here is a Model S chassis. And the Model 3 have a very similar design where the battery pack goes underneath the chassis of the car. We're excited to be making that battery pack when the product launches. Anyways, those are the products we're making here at the Gigafactory. Any questions before you move on? Yeah.
So this is 14% of the factory, and it's already being used. Lots of pots. On our way to Europe.
For low-cost batteries and net zero energy, we developed our own construction company. We hired construction engineers, we hired people to design the building, and we became, in addition to an automobile company, an energy company, a software company, we're also now have a construction arm. And we've built this building from the ground up with Tesla and with taking a very fundamental approach. And we believe that integrating the building to the final product is the only way we're going to be able to make the best product and the lowest cost product.
I'd like to say thank you guys for joining us today and coming to see our second home.
The production process, so the air handlers, the compressors, the chilled water systems, all of that. And then you have more production processing.
Which is a copy, more or less, or
Either different processes.
Okay, that was the end of the tour. Well, we saw how the cells were being created. That was really interesting. And then secondly, how the cells were being used into stationary energy boxes, and later they're going to be used in the Model 3, which is not happening at this moment today. They only built 3 sections. There's 9 more to come. You know, so it's going to be 7 times more building space. And that building, we also only saw 1 floor because this thing has 3 or 4 floors. So there's all kinds of support mechanism, but there's also more production line. So it's a huge building. Most interesting thing was that they have their own building industry company. And I talked to some of the guys, the experts. Some came from the shipping industry, some came from the building industry, some came from the electronics industry. And they really were asked to make a Model S kind of factory, a really new thinking. So there were all kinds of different people from different industries who came together, and they're designing this factory. And they're designing this factory to be not be the only one, but to be one out of a series. And it's already quite big, and it's already quite exciting. It's interesting. I mean, why would I go to a factory which is being built? You know, why would I do that? But lots of people do that, and it's really interesting and it's really exciting, because you really think that these people are doing a whole new way of designing, building factories, and it shows. But it's amazing. I mean, they make their own factory software, they make their own robot software, they of course make their own products. They say we need scale, so we're going to build a factory which is twice the whole production of the whole world. These guys are big balls, and everybody you talk to who's working on the design is extremely enthusiastic and is really empowered, feels empowered. So that's really cool. Let's see if I can find the Model 3, because that's really useful. It's nice they have a lot of offices at the factory floor, on the factory floor. So this is nice. We're inside the showroom, and we're going to take a look at the Model 3 and how different it is. So the Model 3 is now ready, and not to be said that this is the final thing, but it looks exactly like the Model S. It's very familiar, only it cuts off here. So it cannot open completely because it has this huge screen, which is really nice. No idea how the doors will open. It's definitely a lot smaller than the Model S, but I think inside it seems to be quite wide, quite good. Great. Looks like the Model X, huge screen, but even further it goes all the way to the back. $35,000 car, it's just amazing. Now the front looks definitely different, looks more like a Porsche. and but of course it has a frunk. This is actually not a real car. It's an empty shell. Dark, we cannot look inside it. But I can tell you, if you would see this car driving around the highway, it doesn't look like a $35,000 car. It looks like a lot, has all the charm of a Tesla Model S. Really would like to see it inside. Okay, so this was the tour of the factory. Hope you like it, and hope you find it interesting. And we'll be back here when more happens. But it was a pretty good, tour. They were quite open. We could see everywhere. We could walk everywhere. We weren't in little boxes, little buses. It was good. Thank you, Elon.